Okay, in this section, we will learn how to add and subtract polynomials. So let's first find out what check the definition of a polynomial with the variable x. Okay, the polynomial is, let me change the color. Okay, polynomial can be written as this. Okay, here is an times x to the nth power. Okay, this is a variable x, x to the nth power. And the next add it plus or minus, and the next is x to the n minus. The exponent is decreased. Exponent is decreased, and finally, when you get here at the end of this, x squared x, and this is just a number. Just a number. Okay, so you can write the polynomial. Okay, so this is a polynomial, and usually the polynomial is written in descending order by the degree. So the largest exponent comes first. So the term with the largest exponent is written first. Okay, so the degree of the polynomial means is the exponent, the largest exponent that is the term. And if a term has the largest exponent, then that exponent is the degree. So for example, let's say here is x to the 5th power plus 4, okay, 2x to the 5th power, 4x cubed plus 3. Okay, then this term has the largest exponent. The exponent is 5, so degree of this polynomial is 5. So degree is the the largest exponent of the base x. Okay, and the leading coefficient. Okay, the coefficients are all the numbers that is multiplied by the variable exponents, x to the nth power. So an minus 1, an minus 2, all these are the exponents. These are the coefficients. And the leading coefficient is the coefficient of the term that has the largest exponent. So x to the n is the largest exponent, so an is the coefficient, leading coefficient. So in this example, the leading coefficient is what? 2, because this term has the largest exponent, 5. Okay, constant term is this. Everything is variable terms except one, which is constant. So if a term contains variable x with positive exponent, then they are variable terms. And this 3 does not have variable x, so the constant term is 3. So usually constant term is a number. Okay, so if a polynomial has one term, then it is called monomial, mono, single. And if a polynomial has 2 terms, then we call the polynomial it's a binomial. And 3 terms, then trinomial. And there are 4 terms, 5 terms, 6 terms, and so on. So all together, we call this polynomial. Okay, then exercise 1. Okay, we have a polynomial here, and we can write this polynomial in standard form. Okay, standard form. Okay, standard form is write the polynomial in descending order by the degree. So the largest degree term comes first. So this is the largest degree. So we will write this term first. Negative 2 to the 7th power. And the next one is this. So plus 5x squared. And next is this. So minus 2x. Finally the constant plus 4. So make sure the power is in descending order. Power is in descending order. Okay. So in this case, we don't have to write 1. Okay, the degree of this polynomial is the exponent of the largest degree term. So 7, the degree is 7. The largest exponent is 7, so 7 is the degree of the polynomial. And the leading coefficient is the coefficient of the term which has the largest exponent. So negative 2. Okay, the next. Okay, write this in standard form. So write the term which has the largest exponent. and then 16. The degree is, the power is 3, exponent is 3, so degree is 3. And the leading coefficient is, okay, the coefficient of x cubed is what? 1. So this is equal to 1 times. So 1 is the leading coefficient. How about this? The standard form, there's only one term, so write just 1. The number 10. So one term, which is 10. The degree is, the degree of constant is 0, because x times 10 times x to the 0 power, then this is equal to 10. So the power of x is 0. So constant, the degree of the constant is always 0. The leading coefficient, and the leading coefficient is, actually, we can rewrite this 10 as 10 times x to the 0 power. So the leading coefficient is actually 10. Okay, 10. Because there is a term x to the 0 power which is 1. So we can assume that 10 is the coefficient of x to the 0 power. So this is the only one, so the largest one. So this is the leading coefficient. Okay, in this example, we will add two polynomials using a horizontal format. The horizontal format is simple. What we do is combine the like terms, put the like terms together, and then combine it. So in this case, we have a parenthesis, but actually this parenthesis, we can get rid of this parenthesis, because if we can assume that this parenthesis is multiplied by 1, and then once you distribute 1, then still we have the same terms inside the parenthesis. So we can get rid of this parenthesis. And from the second polynomial, also same. This polynomial is multiplied by 1. So we can remove the parenthesis. Okay, and then we can put the like terms together. So here is 2x cubed. And when we combine the like terms, the like terms are the terms which has the same exponent. So it is x squared plus x squared, same exponent. And then here is only one x. How about the number? Constant is -5, -5, and 6. So we can just add up the like terms. So x cubed term is, there's only one, so leave it as it is. And here it is x squared plus x squared. So this is equal to, there are 2x squared, so 2 times x squared plus x, and add these two, then plus 1. Okay, let's do our next example, letter B. And then letter B is 3x squared plus 2x plus 4. Plus, there are three polynomials. Okay, so from here, we can remove the parentheses because this parenthesis is not multiplied by some numbers not equal to 1 or 0. So we can just remove the parentheses and put all the x's together. Remember the x squared first, x squared together. So 3x squared from here, and plus 3x squared over there, and another x squared term. Okay, now x term. Let's find the x terms and then put them together. So here is 2x, so plus 2x. This one is minus 2x, minus 6x. Here is 2x, so plus 2x. And then constant term, here is 4, here is 3, here is minus 4. Then combine the like terms. So let's add up all this. So when we combine the like terms, we just add the coefficient of the like terms. So 3 plus 3 minus 1. So 6 minus 1 is 5x squared. Okay, next, combine the x terms. So 2 minus 6 plus 2 is, So negative 2 minus 6 is negative 4. Negative 4 plus 2 is minus 2x. And this one, 4 minus 4 is 0, so this is 3. So this is the simplified, this is sum of these three polynomials. Okay, let's try next one. Okay, in this example, we will use a vertical format to find the sum of these three polynomials. So vertical format is write each polynomial vertically. So there are three polynomials, so we will write 3 lines. Write this one in 3 lines. So the first polynomial is 5x cubed. Okay, when you write the polynomial, make sure that if there's a missing term, okay, write in descending order in degrees, and if there's a missing term, then put zeros or put a space for that missing term. So 5x cubed plus 2x squared minus x plus 7. Then write the second polynomial in the second line. So 3x squared. Okay, when you write the term, make sure they're aligned vertically. So 3x squared is x squared term. So write this in the square, in the column where x squared is. So this is 3x squared minus 4x plus 7. Okay, the third polynomial will be written in the third row. So negative x cubed. So negative x cubed, so write this one in the column that has cube. So negative 3x cubed plus 4x squared. And the negative 8 is a constant, so I'm going to write negative 8 at the end. And the vertical format is add like terms vertically. So the first one is 5 minus 3. Okay, 5 minus 3 is 2x cubed. The second column is 2 plus 3. 2 plus 3 is 5. 5 plus 4 is 9. X squared. And negative 1 minus 4. Negative 1 minus 4 is negative 5x. And then final numbers. So 7 plus 7 is 14. 14 minus 8 is 6. Plus 6. So this is the sum of 3 polynomials. So there are lots of exercise, so please practice. It doesn't matter whether you use vertical format or the horizontal format. As long as we combine the like terms, then that is fine. Okay, in this exercise example, we will subtract a polynomial from another polynomial. So let's write the expression correctly. Then when we subtract this polynomial from this, always write the second part, the expression in the second part first. So 3x cubed minus 5x squared plus 3. So the second polynomial minus the first polynomial. So minus and then put parentheses because we are subtracting the whole expression. So we are subtracting this whole polynomial. Okay, so this is the right expression. Okay, subtract this polynomial from this polynomial. Okay, then we can remove this parenthesis, 3x cubed minus 5x squared plus 3. And we've got to remove this parenthesis. But in this case, this is multiplied by a negative number, negative sign. You know, the opposite of something. So we got to multiply each term inside the parenthesis by negative. Okay, by negative, so x cubed becomes negative x cubed. So negative x cubed is minus, and then 2x squared is multiplied by minus, so it's going to be minus 2x squared, and minus x becomes plus x, minus 4 is plus 4. So whenever you multiply a parenthesis by negative, then make sure to change the sign of each term. Okay, then we will do the addition. Okay, so combine the like terms. So let's combine the x cubed term first. X cubed is, okay, the coefficient is 3 and minus 1. 3 minus 1 is 2. x cubed. Okay, the next term is x squared. So we have an x squared over here. Negative 5x squared minus 2x squared. So negative 5 minus 2 is negative 7. So put minus 7x squared. And the next term should be x term. Do we have x term? Yes, over here. There's only one x term, so write it down. And then how about the constant? Next is constant. So here it is number 3 and 4. So 3 plus 4 is 7. And make sure you write each term in descending order. Write the polynomial in descending order by the degrees. Okay, then let's try another example. Example 5. Okay, in this example, let's subtract two polynomials using a vertical format. So write the first polynomial on the first line and make sure there is no, if there's a missing term, then put a space. And then write it in descending order. So largest degree term comes first. And then minus. Okay, on the second line, I will write minus the parentheses. So minus and opposite of the parentheses is change the sign of each term. So I will change the sign of each term because we got multiplying by negative. So minus 3x to the fourth power. And the second term is plus 2x cubed. The third term is minus 3x. Minus 3x, but this is x term. So there's no x squared term, so leave a space here. And then x term goes right under this negative x. So minus 3x. And then plus 4. So 3x becomes minus x, and the location of the minus x is below this x term. Okay, and add these two lines. Then 4 minus 3 is just 1, so x to the fourth power. And negative 2 plus 2 is 0, so this place is 0. And there's only 1, so bring it down, 5x squared. So negative x, negative 1 plus negative 1 plus negative 3 is negative 4x. 8 plus 4 is 12. So this is the subtraction of two polynomials. Okay, in this example, this one has addition and subtraction together. So there are three polynomials added or subtracted together. So how can we simplify this? Okay, first of all, get rid of the parentheses and then combine the like terms. So the first polynomial, we can just remove the parentheses. For the second polynomial, the second polynomial is multiplied by negative. So multiply all these three terms by negative sign, which means change the sign of each term inside the parentheses. So minus 4x squared minus 5x plus 1. And the polynomial is plus something, so we can just remove the parentheses. Then this is minus x squared plus 4x plus 4. So that is equal to, now combine the like terms. So let's combine the x squared term first. So 2 minus 4 is negative 2. Negative 2 minus 1 is negative 3 x squared. Okay, how about the x term? Here is negative 7x. So negative 7x is negative 5x. So negative 7 minus 5 is negative 12x. Here is another one. So negative 12 plus 4. Negative 12 plus 4 is negative 8x. Okay, the next one is constant. So here it is 2, 1, 4. So 2 plus 1 is 3. 3 plus 4 is 7. So this is the result. Okay, let's try letter B. Okay, in this case, there is a bracket. There is a big bracket, and inside this bracket, two polynomials are subtracted. So by using PEMDAS, okay, PEMDAS indicates that simplify the parentheses first. So we have a large bracket. So let's simplify this bracket first. And this one is okay, so we can remove the parentheses for this polynomial. And then minus bracket. So let's simplify simplify inside the bracket. So this is the inside is 4x squared. Get rid of this parenthesis. 4x squared minus 3x plus 8. And for this, there is a minus sign, so we gotta multiply each term by negative. So plus x squared minus x and minus 7. So in order to simplify the bracket, we will do what? Combine the like term. So there are two x squared terms, so 4 plus 1 is 5x squared. And also there are two x terms. So negative 3 minus 1. Negative 3 minus 1 is negative 4x. Two constant terms. 8 minus 7 is plus 1. Okay, next step is simply get rid of this bracket. Okay, get rid of that. And this bracket is multiplied by minus, negative, so change the sign of each term in the bracket. So minus 5x squared plus 4x minus 1. And finally, combine the like terms. There are two x squared terms, so negative 1 minus 5 is negative 6, x squared. Okay, there are also two x terms, 4x plus 4x is 8x. And constant term is negative 3 minus 1, so negative 4. So this is the simplified polynomial. Okay, in this example, okay, here's a trapezoid. So write the trapezoid expression for this the perimeter of this trapezoid. So I'm gonna write an expression for the perimeter. So okay, the perimeter is the sum of all four side lengths. So there are four sides, and each side is written in some expressions. I'm going to add up all these four. So the top is 2y, and this one is 3x plus 1. This one is 4y plus 3, and the last expression is 3y plus 1. So P equals combine the like terms, so 2y, 3y, okay, this is y, 2y plus 3y, 4y, 3y. So add up all these y terms, then 2 plus 3 is 5, 5 plus 4 is 9, 9 plus 3 is 12. So 12y, and the constant is 1 plus 3 is 4, 4 plus 1 is 5. So the expression for the perimeter of this trapezoid is 12y plus 5. And the second question is, when the value of y is 5, find the perimeter. So the perimeter is, the y value is 5, so replace this y with 5, and then evaluate. So 60 plus 5 is 65. So the perimeter is 65. Okay, so, so when we simplify, when we add or subtract polynomial, make sure remove the parentheses and add and combine the like terms.